You're welcome, sir.
Yes, well done. I've made you.
Yeah, thank you, sir.
To pinpoint the outcomes of this particular event. It's at this point I want to implore you to chat out and reach out to your friends and well-wishers wherever you are from. Ask them to join the meetings, faculties, departments, government agencies, all your colleagues and networks. Please get across to them and then invite them to this meeting, because I believe that this meeting will help us to shape a new narrative for the Nigeria of our dream. It's at this point I want to welcome everyone, wishing us a fruitful and a fantastic deliberation. Our chair is unavoidably absent, and our vice chair is here in person to drive, us as we make these deliberations today. Thank you very much, and I wish us a fruitful and fantastic deliberation moving forward. God bless you.
Thank you very much, Dr. Kennedy. Our founder came, he's back, he's in now. Actually, I'm happy to welcome Dr. Festus. He's currently in Nigeria, and he came in to drive some other researches and things for the association. This association was actually founded and held on, working, trying to achieve its mandate towards its goals, its visions, along the core values. Well, the co-founder is here, Dr. Festus, and he will be taking up the next one, introduction of AMNOM, the association. Thank you very much. Dr. Festus?
Thank you very much. Thank you very much. And I welcome everyone to this program. And AMLON has come to stay. And I believe that that is the future of the world at the moment. And we started this association with General Ishola Williams, whom you have known very well, to be a versatile Nigerian who is concerned with the future, a man that has a very strong vision. And he was very passionate about this association. Having served in the military as an engineer and as a computer engineer, he has traveled all over the world, around the world, and he realized the impact artificial intelligence is going to make in the current and future dispensation. The core purpose of Artificial Intelligence Association is to drive innovations and excellence for the benefit of humanity. And we are working collaboratively with different organizations, different institutions. And we know that this is going to create a strong networking and collaborative opportunities throughout our partnership and with institutions, organizations, and government. At the moment, we've got some recognitions as well up to the World Bank. Right now, I'm here for a meeting, which when we finish everything, is going to put the association on a very strong limelight. And in terms of career development, we'll be establishing a career development and advancement, around the country. And we have got to do this one. A lot of research is going on. And as you can see from our website, if you go to our website, you see we have a lot of intellectuals, think tanks, who have achieved in various endeavors to man this organization and steer it to success. So I will not talk too much. All what I just advise everyone is make sure you are fully registered, because the ship is sailing right now. And what it says, some of the benefits, it might be very tough because the competition is getting stiff. As today, I've learned that a lot of people have registered. And if you are still here and you are not registered, please try as much as possible to register. Thank you very much. God bless you all.
Thank you. Thank you very much. That was one of our founders. And he has done so much with the organization, trying to drive it on to what it is today. and what we are planning for the future. The next thing on the agenda is on the program is the citation of the presenter. And just as I said during the opening remarks, as before the opening remarks, we have just a presenter for this 5th event in the year. And I will be presenting his biography, just a brief profile. I'm talking about Dr. Bashir Mohammed.
Very rough.
He will be speaking on AI innovations for Africa and future quantum applications.
You better shut down
Dr. Bashir is an accomplished staff AI research architect and engineer at Intel with a passion for exploring the potential of artificial intelligence in science. He earned his bachelor's degree in electrical and computer engineering from Federal University of Technology, Minna, Nigeria. His MSc in control systems from the University of Sheffield, where he interned with Rolls-Royce University Technology Center, and a PhD in computer science from the University of Bradford, United Kingdom. Prior to his current role, Dr. Bashir conducted groundbreaking researches at Lawrence Berkeley National Lab, where he focused on artificial intelligence and machine learning applications in intelligent networks, automatic control systems, quantum communication networks, and data provenance in high-performance computing, HPC, and distributed systems. His expertise lies in harnessing artificial intelligence algorithms to optimize the control and performance of distributed network infrastructures, facilitating high-speed big data transfers and minimizing network downtime and congestions for critical scientific workflow at the escalator level. Bashir's dedication to advancing scientific innovation extends to his work as a staff computational research engineer at Berkeley Lab, where he played a crucial role in the quantum application network testbed for novel entanglement technology project, QuantNet. This groundbreaking initiative aimed to build a physical quantum distributed network testbed based on entanglement, paving the way for revolutionary advancements in quantum networking. Recognized for his outstanding contributions, Dr. Bashir was honored with the Berkeley Lab Research Slam Award. In 2019, he had the privilege of being among the select group of postdoctoral fellows from U.S. national labs invited to Washington, D.C. to share his research insights with legislators and the Capitol Hill audience. His exceptional talent in digital technology was acknowledged by the UK government in 2020, endorsing his world-leading expertise. In 2023, Dr. Bashir was chosen as a Science Policy Fellow by the Society for Industrial and Applied Mathematics, SLAM, further affirming his dedication to bridging the gap between scientific research and policy making. Passionate about engineering and driven by a vision to leverage AI and intelligence systems for the betterment of science, Dr. Bashir continues to make significant strides in his field, shaping the future of technology and its impact on society. I therefore present our honorary speaker for today, Dr. Bashir Mohammed, to speak on artificial intelligence innovations for Africa and future quantum applications. Dr. Bashir, sir.
Okay, thank you very much for that beautiful introduction. I was trying to unmute myself, so I just dropped a message, but thank you very much for unmuting me. I'm going to put on my video. So I'm currently based in California in the USA. So it's 3:22 a.m. here in the morning. So, and it's pretty very early, but I'll put on my video so that at least people can, I'll put it on for a while, then I'll switch it back off and share my screen. So, so that's me, so that at least people don't know that they're not speaking with a ghost. So I'll put it off in a while, then I'll just quickly share my screen. One sec. Okay. So please let me know if you can see my screen.
Yeah, we're seeing the screen.
Okay, thank you very much again for that wonderful introduction. I'm really super excited to be here today and to be sharing, you know, some of the previous work I've done in this area. And when I got contacted by Amlon, you know, I was really excited because one of my main aims and objectives is to look for opportunities where I can, you know, contribute, give back to the country, you know, contribute as much as possible. So, and I was really excited to jump on and take this golden opportunity. So thank you very much for the invitation. So again, my name is Bashir Mohammed. So I recently joined a company called Intel Corporation. And so I have very little to share about Intel. But before then, I used to work at Lawrence Berkeley National Lab, which is a US Department of Energy, US government national laboratories. So the US government has 17 of such labs in the United States. So I was lucky and privileged to work in one of them. So I'll share also a bit of more insights about the lab, some of the people I was privileged to work on. And as of today, the lab has about 15 Nobel Prize winners. They do cutting edge research in computer science, biology, physics, chemistry, heavily applying artificial intelligence in all these areas. So so that's the picture of the former lab. So I'm in love with it so much I had to put it as a screen. Okay. So I'll give a little bit about myself. I know they've already done justice to that, but I'll just quickly, I'm not going to spend too much time on this slide. So I'm an experienced AI and an ML researcher with over a decade of experience. And I've just recently joined Intel as a senior staff AI architect. And previously at Lawrence Berkeley Lab, my research heavily focused on AI and machine learning for intelligent networks, control systems, quantum communication, and also data provenance in HPC and distributed systems. So before then, I used to also work as a postdoc before I became a research scientist at the same lab. And I worked on one of the coolest projects, which is the deep learning and AI high performance networks project, which we call DAPNE. So I like telling my friends at Google that just the same way they're trying to build or design self-driving cars, we were trying to build a self-driving networks for science. I'll also explain what that means later in my presentation. And yeah, I was basically, and these are some of my achievements. I had my first degree in electrical and computer engineering from Futmina before moving to the United Kingdom to do my master's in control systems. So I interned with Rolls-Royce, and a lot of the time when I tell my friends, when I mention Rolls-Royce, the first thing that comes to their mind is expensive cars, luxurious cars, right? So I worked with the aircraft engine, most of the aircraft, I worked with the aircraft engine section. So I worked on the Trent 900 series engines where I developed some control and optimization algorithms for them before I left. So if you've ever been on a Boeing 747 or Airbus 380, then probably you've flown one of the engines which I've been privileged to work on, which is the Trent 900 series. And these are some of my experiences. And those are my social media links. Please feel free to reach out. So this is a brief agenda I have for today. Again, I'll make the interaction as, I'll try and make the presentation as interactive as possible. And let's see how things will go. And I'm also happy to extend this conversation even beyond this presentation. I'm happy to be have outside meetings out of this and discuss what I think. Okay. So I will just start with a brief introduction and I will go into all this and then before I conclude my presentation. So one of the things I'll also be looking at is what my vision for an African internet network is. Some of us might have started thinking about that, some of us not, but I would like to know what if the internet was invented by Africa and by Africans? So what if the internet was invented in Africa by Africans, and what would an African version of the internet look like? And also, what if the internet was, invented and, we use our local language, basically, to communicate. So those are just some of the things that inspired me to start thinking of this topic. And also there is a link I'm going to share about an article, which is very, very interesting for anyone that is interested to actually look at what that will be. So I think I will be sharing those links in a moment via the chat, so people can just have a look and just go through. Okay, so the first thing I'm going to go on to, let's see. So I'll start with this. Data is the new oil. So we're talking about artificial intelligence, but under the hood of artificial intelligence, there's a lot of things happening, right? There's data. So I want everyone to press in this chat window. If you agree with this statement, you just press yes, which is Y. And if you don't agree, just say no. So like I said, I want to make it as interactive as possible. So if you have access, please check. And I think I'll rely on someone to tell me if we have more yes or more no, because I have multiple screens here. So let's see. Okay, I can see that we have a lot of yes. Okay, that's really cool. So there's a British mathematician called Clive Hornby. So he said data is now the new oil. And the main reason is because CEOs of industries, captains of industries, nobody wants you to tell them what has happened yesterday. Everyone wants you to tell them what's going to happen tomorrow. How much am I going to make? What impact is AI or machine learning going to have on my business? What is the business insights? So and all this thing is driven by data. When you have data, you can see the insights and you can predict the future, basically. So I will come back to this later in my presentation. So I'm going to start with a story that actually made the headlines in the US many years ago. So this happened in one of the biggest supermarkets in the US. So a dad started receiving coupons which were sent to his young teenage daughter. So he became very worried and decided to visit the supermarket. On arriving at the supermarket, he was really upset and demanded, "I want to see the manager." So, and he asked the manager, "Why are you sending coupons to my teenage daughter? She's still in school. She's not even 18 yet, but you keep sending her, coupons which are related to, how to coupons, right?" So the manager apologized and assured him that, "We are sorry, we're going to take you off the system, will take to ensure that she doesn't receive such coupons in the future. After 2 months, the manager now called the dad, giving him a courtesy call and said, Dad, on behalf of the supermarket, we've just called as a courtesy to say we're sorry for what happened the last time and all that. And guess what the dad said? The dad said, I am sorry, manager. I should be the one apologizing to you. It turns out that my daughter was expecting a baby. Literally, she was pregnant. So I'm sure some of you will start wondering, how is it even possible that the supermarket detected that this teenage girl was expecting a baby and started sending her coupons that are related to pregnancy? So how did the algorithm even figure this out? And this is because we have shopping patterns, for people. Anytime you go to, you have shopping patterns. When you go to shop, you use some of your royalty cards, and over time you build a shopping history. That shopping history over time, when you place an algorithm to consume that data, it can begin to understand and learn and suggest, products based on your shopping patterns, right? It will start giving you recommendations of possible things you might buy because you're buying this. So I think the algorithm figured out that, she has started buying maybe, for example, some odorless perfumes or some multivitamins, and it probably calculated that maybe this teenage girl might be in her 3rd or 4th trimester, and it started sending these coupons. I don't know if that makes sense. So this is the power of data, right? And you will all agree with me that, data is now the new oil, but the main question here is, today in the world we live today, we have huge amount of data that is constantly generated. But the question is, how do you make meaning out of this data? Because if you have a data and that data has not been processed or analyzed, then it's useless. Okay, so that's basically it. So the name of this supermarket was Target in the US. So they had this, this whole story that made the news, and it was really very interesting to relate that with the revolution we are having in, AI, machine learning, and also data science. Okay, so I also love this quote from Peter, and he said, information is the oil of 21st century, and analytics is the combustion engine. Okay, so basically, again, going back to my analogy, you have huge amount of data, but if you don't analyze it, it's useless basically before you can get insights. So my next slide is also very interesting. I'll be playing a short clip, but again, I want to throw the question to the audience. Does anyone knows what AlphaGo is? Please press Y in the chat window if you know, and if you don't know, it's fine. I'm gonna shed more light on what it is, and press N or no if you don't. Okay, I can see that we have some no's. Okay. Okay, can anyone tell me whether we have more no or more yes? I'm sorry, I have multiple screens, so. Okay, we have more no. Okay, thank you. Okay, so let me just play this little clip. Please be a little bit attentive, and let's see. I pray, please.
Go is the world's oldest continuously played board game. It is one of the simplest and also most abstract.
Beating a professional player at Go is a long-standing challenge of artificial intelligence.
Everything we've ever tried in AI just falls over when you try the game of Go.
The number of possible configurations of the board is more than the number of atoms in the universe.
AlphaGo found a way to learn how to play Go.
So far, AlphaGo has beaten every challenge we've given it, but we won't know its true strength until we play somebody who is at the top of the world, like Lisa Dot.
like no other, is about to get underway in South Korea.
They said all is to go what Roger Federer is to tennis.
Just the very thought of a machine playing a human is inherently intriguing.
The place is a madhouse.
Welcome to the DeepMind Challenge. The whole world is watching. Can Lee Sedol find AlphaGo's weakness? Whoa. Is there, in fact, a weakness?
The game kind of turned on its axis.
Well, look at your face.
That is not a confident face.
It's developing into a very, very dangerous fight. Hold the phone. Lee has left the room.
At the end, he just about to cry. I didn't even know something went wrong. Yeah, it's made a mistake. It's got to influence the narrative.
These ideas that are driving AlphaGo are going to drive our future.
This is it, folks.
Okay, so I decided to show that little clip. So there was a game of Go. So some little, just a summary of the video. So some little folks, they came together. They're all based in the United Kingdom, and they started a company called DeepMind, and they designed basically an algorithm that was able to beat a human player. So there's a game called a game of Go. So they designed an algorithm to play the best world champion of game of Go, and they were able to beat, their algorithm was able to beat that human player. And that's what, like you had in the video, just like you have Roger Federer in tennis, this guy was the champion in the game of Go. So the coolest thing these guys did from DeepMind was to come up with an algorithm. So one thing that was really, that stood out in the video is the number of possible configurations of that board was more than the atom in the universe, because they had to sit down, configure all the design all the configuration, the moves, the algorithm is going to make just to beat the best player in the world. So I used this algorithm, I used this model, the same technique they used. Those were some of the technique I used while at Lawrence Berkeley National Laboratory, and I was inspired by some of the work they did. And right now they are now part of Google. Okay, so when you Google DeepMind, DeepMind is the name of the company. It was a startup that started, and Google now acquired them. So they are now part of Google, now doing interesting and amazing research. So I'm sharing that because that was the foundation of my entire research I did, which was an algorithm called reinforcement learning. And that was how most of the work I did at Berkeley Lab utilized that algorithm. So that's a brief overview about the game of Go, where it was originated, and what was the challenge, and how it made history. Okay. So my next slide is basically talking about what is data science, what is machine learning, but I'm not going to go through all this because I believe we all have experts here. So I think I have one interactive link which I'm going to share in the chat window, so folks can have a look at it later. And again, feel free to ask me any question if you have. So I'm sharing a link on the chat window. Let me see if I can have a look, and you guys can have access to that maybe later. Let's see. So it's just basically an infographics that explains, what the whole concept is all about. So again, you can go through that at your free time a bit later. Okay, so I'll move on to some of the cutting edge research we did at the lab. Before I move on to mine specifically, then I will now talk about quantum networks, some of the research I did in quantum networks, and also my vision for an African internet. So just a little bit about Berkeley Lab. Berkeley Lab is a United States it's a US government national lab that conducts scientific research on behalf of the US Department of Energy. It was founded in 1931, and it is the oldest of the US Department of Energy network of 17 national labs. And as of today, there are 14 Nobel Prize winners at the lab. They do cutting edge research. They do one of the broadest research. They have one of the broadest research portfolios in the world. They do cutting edge research in computer science, environmental science, biology, chemistry, and physics. And their mission is basically to bring science solutions to the world. So, and I'll be sharing some of the research that I did while at the lab, and why one of the reasons why I accepted to even give a talk here was because I saw that, you know, the founders of this association, you know, also had some links to do with, you know, military and all that, which is also had linked to government. So in a way, some of the things I did, I also look at a way where I can transfer some of the knowledge, you know, so based on my experience, based on things I've learned from the US government, you know, how can I transfer some of these things, you know, back home, and which our government, the Nigerian government can also benefit from that. Okay, so I decided to share this. I'm also going to paste the link here. So this was the report that really helped me. So for those interested in taking a look, so the Department of Energy hosted a series of town hall meetings, which was attended by over, you know, thousands of scientists and engineers in the whole of the US. And their goal was to examine the scientific opportunities in the area of AI, big data, and HPC in the next 10 years, and capture the big ideas and grand challenges and the next step to realizing these opportunities. So I really find that very interesting. If that's something also we can start doing, which I know maybe we're already doing in Nigeria, which is to bring together all the expertise, both in academia and industry, and they should now start thinking what's going to be happening in this field in the next 5 years, come up with a report that will also drive and, you know, motivate research in that direction, right? So because these are experts that will come together, sit together, deliberate, talk, share experiences, and they will now design a roadmap. So 99% of the research you see being done in the United States, it's not just research of yesterday. They've thought about it like 5 years ago, and they now start doing some strategic investment in such areas. So those are also some of the things, to be honest, we can learn from, whereby, you know, we strategize in, okay, what is going to be the future of AI in the next 5 to 10 years? What is going to be the changes? And we can now start driving and motivating research in those areas. So I'm going to share the link for those of you interested in you know, just having a look. It's a public document, it's not classified, so you can feel free to look at that. Okay, so I'll move next to the work I did, which was the research I did with a network called Energy Science Network, which is a US government dedicated internet network for science. So, and I felt that spawned the motivation behind me, where I started thinking about what an African network internet will look like. So the ESNet is a high-speed network serving thousands of US Department of Energy researchers and collaborators worldwide. It is a complex network because it has more than 40 connections from the Department of Energy, and over 140 research and commercial sites are connected to this network. So they have there's locations in Boston, in CERN, in London, you know, in New York, in Netherlands. But things like delays, traffic congestion, latency were jeopardizing some of the mission of driving this network effectively. So the main objective of this one of the project was to do, in a simple way I explain it, Google Map for ESNet, where the most optimal network route is being detected, and also where the most, because our research has shown that the shortest path might not be optimal, right? So the main aim was to come up with an algorithm that will figure out when is the best time to transfer data from point A to B, what is the most optimal route to transfer that data from point A to B, and to detect whether there is a failure in any of the links, any of these network links, or whether there's going to be traffic. So I like telling my friends that basically what we built then was what we call a self-driving network. So we wanted the network to be self-configuring, self-optimizing, self-healing, and self-protecting. So before I joined the lab, if there is a problem on this network, the network engineer has to figure out what is the problem, then try to solve that problem. But when I joined the lab, we came up with that algorithm. And whenever there's a problem on the network, it self-heal, self-configure, self-repair, and self-fix itself. Again, that's the power of AI and user reinforcement learning algorithm to actually figure that out. So in summary, basically, the network, one of the main things they wanted to minimize in the network was to have a network that is actually completely free. So I use the road network as an analogy to drive home that point. So as at 1990, if you look at it, the total ingress traffic within the whole of the US Department of Energy science network was about 25 petabytes. But if you look at it, as 2017, it increased to almost about 40, and it's been projected that in 2030, it will even go much more beyond that. Okay, so this is one of the problems they are trying to solve by hiring folks like me to bring in more intelligence to the network, so that if anything happens, we will be able to make the network to be almost optimal at any point at all times, and also avoid things like delay and traffic congestion. Okay, so again, I have one question for the audience. Like I said, I'm going to try and make this presentation as interactive as possible. So I want you to assume, let me take this off. Okay, so I want everyone to assume you're in Abuja right now and you want to travel to Lagos. Okay, so on visual inspection, I want you to type in the chat window, where is the path you're going to use? So you have 5 paths, path 1, 2, 3, 4, 5. So if you want to travel from Abuja to Lagos, please type in the chat window. Are you going to be using path 1 or 2 or 3 or 4 or 5? So let me see what response we have more. Okay, so we have one person saying 3. Is there anyone else? Okay, we have 3. We have 3. Okay, we have 3. Okay, then this looks like this audience is super smart audience. So that's really very cool. Okay, so let's bring in some complexity. Okay, yes, we have more 3. Okay, that's cool. So let's make it more complex. Okay, so I want everyone again to reevaluate your result, the choice you made. If I'm going to ask you the same question, traveling from Abuja to Lagos, but I've introduced some constraints, some complexity. So we have what we call bandwidth, and we have latency, which is delay. We don't want delay to happen in any network. So can you tell me which path will you choose based on this constraint? Please type in the chat window. Okay, we have part 4. Okay. We have part 1. Okay, someone say part 2. Okay. Okay. Okay, so some people say part 3. Okay, so I think the answer is actually part 1. And the reason is because we have the highest bandwidth in part 1, and we have the lowest latency. So latency means delay. We don't want that to happen in any network. So what I've just demonstrated is the concept I used in building my model, my algorithm within the US Department of Energy network. So whatever we see on visual inspection is completely different with what happens. Okay, so traveling from Abuja to Lagos, maybe the Lokoja route might be the shortest, right? But at that point, time T, maybe at 12 noon in the afternoon, it might not be the most optimal because there might be traffic on Lokoja Expressway, there might be congestion, there might be a lot of things on that route. So that's basically so excellent response, and yes, I really appreciate you guys taking part. Okay, so I don't know how long we are doing in time, please, because I have a lot of slides I want to share, so that if I'm moving slow, I can increase the speed. Okay, so I'm going to introduce the concept, which exactly again I mentioned, which is what I used, but I won't go too much in detail into it. Again, for anyone interested in talking more, please reach out to me. So the concept is simply simple. And this is the same thing the AlphaGo folks used. So we have an environment, okay, and you have an agent, and this agent interacts with the environment. That means it performs an action, and having performed an action, it gets a reward. And over time, so this was inspired by a game called the Atari games. So an agent performs an action, it reads the environment, and it gets the reward. And over time, it learns the most optimal action to play. So this process of doing that, this process of doing that is actually called the exploration and the exploitation before a decision is being made. So one great example is if you have a dog, or you have, something you want to train. If you train that dog to maybe jump a fence, anytime it did the right, it jumped it, you give it a biscuit, that's a reward. So the dog is performing an action, and the environment is the fence you want it to jump. And over time, once the dog performs a very good action, you give it more biscuit. If it doesn't perform, you don't give it a biscuit. So the reinforcement learning algorithm works in a way that if you're taking the right step in the right direction, you get a positive, a good reward. And if you take the negative step in the negative direction, you get a bad reward. And over time, you learn that. Anyway, to drive that point home, let's look at this analogy, right? So you have this environment. So I want everyone here to assume you are this reinforcement learning agent and you want to travel to, let's say, Kano, for example. So if this agent wants to travel to Kano, he has two options. He can either go up or down. So if he wants to go up, he has 5 steps, and he's in Kano, right? If he wants to go right, he can go 1, 2, 3, 4, 5. So indirectly, anywhere it goes, whether up or down, it's still the same steps, right? So let's give a reward and see. So if we're going to give a reward, it's still going to, this is just random, okay? So 0.73, 0.73. That makes sense because whether it takes up or right is going to be the same number of steps, right? And that's why the reward is that. But let's make this a bit more interesting now. So what happens if the agent comes here? If he decides to go up, he has two options, right? If he decides to go up, it's going to be how many steps? 1, 2, 3. But these steps, and if he decides to go right, it's going to take 1, 2, 3. It's the same number of steps, but there's something, right? So if it goes up, that's the best route for it to take. And that's why you see that the reward is actually increased to 0.9 to 1, and boom, is in Kano. But what happens if it goes right? The reason why you see that the reward is small here, is less here, is because there is danger here, which is fire, right? So that's the whole idea. So take it that if you're taking the right step in the right direction, you get a positive reward. And if you take a wrong step in the wrong direction, you get a bad reward. So that's the higher level idea about reinforcement learning. And that's how this agent learns over time that the best route to always take from Abuja to Lagos is to go through Lokoja, right? But not just to go through Lokoja, which is the shortest path, but to go through the most optimal path, where there's no traffic, where there's no fire, right? So that's what research we've learned, that the shortest path might not be the most optimal. We always want the most optimal, which is less traffic, less obstacle, and less fire. So I don't know if that makes sense. So basically, and that's this is just the mathematical equation using something called Bellman equation. So you guys can Google that up and read more about that if you're interested in that. Okay, so it's called Bellman equation, in case if you want to take notes. Okay. Okay, good. So this is a live demo of how that works. I'm just gonna quickly play the short clip and you'll see. So this is just basically assume you are in Abuja and you want to travel to Lagos and you have different paths. You can either go to Lokoja, you can go to Benin, you can go to Ilorin. There are many paths, right? So once I start this, the agent there's going to be what they call exploration and exploitation. It's going to be learning all the paths. It's going to be checking which path has traffic, which path has there's a car crash, which part has latency, which is going to learn all that. And over time, it's going to start predicting which is the most optimal and not just the shortest path. Again, something to note here is we have what we call the controller here, which has a global view of all the nodes. So it's connected to all the locations. And this is where the agent algorithm runs. Because I know the next question you people will ask me is, where does this algorithm runs? Where does it, where does it reside? So it resides in the controller because the controller is connected to all the nodes. So it's able to understand and learn all the exploration, the exploitation that is happening within the network. So this is just a proof of concept. Before we built the actual model, we did this as a demo to show how the algorithm is going to work and how the model is going to be figuring out which is the best path to be moving traffic from point A to B. Okay, so I'm going to move on to the self-driving networks. And after this, then before I move to the African internet, then the quantum network. So again, the self-driving network, the idea behind the self-driving network, again, I've used an analogy for you. Before I joined the lab, whenever there's a problem within the network, the network engineer will figure out what the problem is and try to fix it. But with this algorithm, we designed a model where we interacted with all the different connections, the nodes, and the algorithm is able to figure out whenever there's a problem, it does what we call self-configuring, self-optimizing, self-healing, and self-protecting. So that's the whole idea behind self-driving networks. So think about it like having to drive a car, a self-driving car, a car without a driver, right? Whenever it gets to traffic or whenever there's anything, it's going to figure out and fix itself. So this is an idea of what is self-driving network. So it's an automated, fully autonomous network. It accepts guidance from the network operator. It's self-discover, it's self-organize, it's self-monitor, and it automatically monitor and update service delivery. It's self-diagnose, and it also self-report periodically. So instead of doing all these things manually, we get to a point where, all these things are being done automatically. Okay. Okay, so this is also an analogy just to drive that point home. So from self-driving cars, if you look at the first level 0, you have your hands and your eyes on steering, right? When it moves to level 1, you have your hands on and your eyes on, right? But level 2, you take off your hands off, basically, and your eyes off, right? Of the steering temporarily. Then level 3, you basically, completely take over and start doing something else. Basically, sorry, take off your hands and your eyes and you start doing something different. So if you go to level 4, you basically take off your hands and your mind off as well. Then level 5, basically you go and have coffee or you have lunch. You just put it on autopilot, okay? So we borrowed that and we brought it to network, whereby we have all the routers, the switches, and we mapped that into the problem we're trying to solve, okay? So, and we get to a point where network recognizes and optimizes, which is from level 1 to 2. Then from level 3 to 5, network senses something is wrong with the network and it tries to correct it. So that's the whole idea of self-configuring, self-optimizing, self-healing, and, self-protecting, okay? Again, I'm happy to answer any questions that relates to these once we, at the end of the presentation. Okay, so this is my vision for an African network. Again, before we move, I'm going to share a link which was very interesting. It was one of my mentors that actually wrote this article. So, okay, not here. So the title of the article was What an African Network Will Look Like. So I'm going to actually throw that question to the audience right now, and I want to get you people's response, okay? So the question I have for the audience is, what if the internet was invented by Africa? And what if the internet was invented in Africa by Africa? We all know the internet was not invented in Africa, right? It was invented in the US. So I want you guys to take a step back and think, what if the internet was invented in Africa by Africans? And what would an African version of the internet look like? Okay, so that's the question I have. If you can type in the chat window what you think the response will be. What do you think if the internet was invented in Africa by Africans? And what would an African version of the internet? I just need one word. You can just say anything. Will it be fantastic? Will it be great? Will it be easy to use? Will it be user-friendly? I just need any word. Type that in the chat window. Let me get your perspective of what you think is going to be cultural centric. That's fantastic. I like that. Any more points on what you think the internet invented in Africa by Africans? Because when they invented the internet in the US, they never thought about Africa. We were not even part of the equation, right? It was more about something that works for them. So, okay, that's fine. Thank you for your response. So I'm gonna post this also in the chat window. So for those that are interested, you can actually look at that. So this really inspired me a lot. So the writer, his name is Chukwuma Afibo. He's worked in Google, Facebook. He's now a director in a security, one of the security company. So that was a very interesting, article for us to start thinking, with the blessing we have in Nigeria, in Africa, the talent we have, what would an African internet actually look like? Okay. So this is basically one of the things I started thinking of. So we have how many regions in Africa? Yeah, so it's going to be difficult to be global. Yes, we agree with that. But yes, starting with Africa, start thinking, what exactly is going to be slow? Okay, someone said it's going to be slow. Okay, that's good. So I was thinking that, okay, if we have 5 regions in Africa, we have North Africa, we have West Africa, we have South Africa, and all these regions have something in common, right? If you look at West Africa, we have something in common. North Africa have something in common, like the language, they speak more Arabic. South Africa have something in common. Central Africa, East Africa too, they have, something at least in common. So imagine making all that into different hubs. So we have the North African hub, the Central Africa, the East Africa, the South Africa, and what will that look like? So locally tailored. Thank you very much for that. Someone just posted a comment as well. So just keep posting the comments. Like I said, this is just like a brainstorming session of what this thing will look like. So this was also very interesting for me to find out. So I don't know, I know a lot of you might already know this. So if you talk about LAN, so there's what they call LAN, local area network, there's MAN, there's also WAN, which is wide area network. So there's this something which is called the West African Cable System, which has about 14,530 kilometers. It's a submarine cable that runs connecting about 15 countries from South Africa, ending in London. And I think it was supplied, I think this was far back as 2012. I'm not exactly sure. But if you look at it, we already have some of this, infrastructure and some of this, because a lot of people will ask, okay, if you want to have an African internet, you need to have the infrastructure in place and all that. But funny enough, some of these things are already there. There's also one big company, I know they have presence in Nigeria, it's called Main1, right? So Main1 also have all these things, the fibers that are going, underground. And so the WAX consists of 4 fiber pairs. It was initially designed with about 128 wavelengths per fiber pair. It was running at 10 gigabits per wavelength, and initially designed for the capacity of 5.12 terabytes per second. The initial investment of WAX was about $650 million. But in May, in 2015, I don't know if you guys know Huawei Marine completed the upgrade using 100 gigabits technology, which increased the WAX system design capacity to about 14.5 terabits per second. And in February 2019, I think WAX upgraded. So this was also a very cool infrastructure, that we already have if we want to build something like that. But experts also say this might actually be the least of our problem. Maybe one of the major challenges we will have might be policy, the issue around the policy issue, right? So you want to build something. Africa is very diverse. We have different languages, we have different regions, we have this. How do you build something that's going to be common to everything? So I like the post someone just posted now. He talked about ethnocultural barrier, which is something that, maybe we might have or will bridge. You say you have been given 10 additional minutes. Okay, that's fine. my distance. So I'm just gonna quickly rush up. Okay, so basically these are all the countries the wax passed across. And yeah, you guys can look this up later. And this was basically what we're trying to do. We're trying to model what we call the local area network, the metropolitan area network, the one. So the local area network will be all the hubs and these locations you have within the countries. Then the man will now be within the regions. Then the one will now be the whole of the Africa. Okay, so someone also posted ethical issues and regulations. Yes, that's also a very good. So these are all problems that will come up when you want to design, come up with something like this. Okay. So these are some of the, I'll quickly just run through these 5 minutes and I'll run through the quantum. So this was one of the projects which I worked on in the lab. It's called also deep learning and deep air, which was deep learning and satellite imagery was used to estimate the air quality impact at scale. So imagine a state like Lagos or Kano or Port Harcourt, you know, where they have a lot of emissions going on, right? So with this, they use deep learning. Deep learning was used to analyze satellite images combined with traffic information, cell phone information, and you know, to improve the air quality predictions. So another cool one was engineering agriculture through ML biopics. So in an effort to revolutionize agriculture and create a substantial farming practices that benefit both environmental and both the environment and farms, they applied machine learning to soil sample collected, and this was aimed to reduce the the need for chemical fertilizers and to enhance soil carbon uptake. To improve the long-term viability of land and which will increase the crop yields potentially. Then we also have, this was route at urban scale. This was mainly on travelers. I think another interesting one was the MetaBio, which they used machine learning tools to diagnose the global land surface models. And they used basically, this was all time series information used and the atmospheric information that was provided. And this was all based on how to detect, using soil samples as well to make sure they have more crop yields to improve basically the experience of the farming and to get more production of food crops. So I'll skip all these which are less related. Then I find this also very interesting, which was the US power distribution grid connects thousands of power plants to hundreds of millions of electricity consumers across the US. So they developed a tested a machine learning algorithm to counteract a cyber physical attack on their compromised system. So imagine someone hacking into PHCN, right? Or any of the distribution or the discos and all that. So this was a model that they built to prevent such an attack. So this was mainly related to physics as well. Then, so again, this was my setup. This was another area I used reinforcement learning to stabilize. And this was mainly a physical system, a real system. So we have like a laser in the lab, and this laser has something called noise and phase drift. So if you look at, basically, this is how it's, so this is the real laser, this is the real picture. And this is the spread of the intensity of lights it has. So what we used RL to do is to understand the system, learn it, and now always make it to be this. So we want all the lasers to be highly powered, centered powered, and we used RL to achieve this. So you can see here, it's spread, it's all free running. And with the algorithm and the model, it was able to bring it to this. So at any point in time, we have this because it's useful when you have a high-powered laser at the center, okay? So, and this is what the demo looks like. This is the RL again algorithm. It studies, it learns, and it takes it to a phase control, which is mainly making the center in the intensity really, really high. Okay. Again, I have a lot of cool things to share, but I'll share the slides anyway. So this was also another cool project which I was part of. So there's actually no economic advantage for you to hire someone to be picking stuffs and be sorting seeds. So these are all garbage. So right now they have a model, a computer vision model with a camera that does the peaks, right? So they started with about 30 peaks per second. So this is a recycling company in California. It picks up this in like, 30 peaks per minute, I mean, but right now they are doing about 1 peak per second. How remarkable that is, right? So it keeps picking, what is it called? Picking all these things within, just within 1 minute, it takes about 60 items and is able to sort them out, and there's economic advantage from doing that, right? Because we know that some things that are supposed to go into recycle might not, end up going there. Okay, so this was also by a company in Nigeria that did this. I find this very interesting as well. They use that to detect breast cancer. It's called Algorithmic. I think that's the name of the company. So you see what they do. So this is actually using in not breast cancer, tuberculosis, I mean. So this was also very cool. Again, this is all the power of artificial intelligence. And these are all, a lot of us use Meta, Facebook. They know you more than you know yourself. Once you upload a picture, they know that they tag your friend, they tag your family. This is all power of AI. And there is also a very famous company in Boston. They call them Boston Dynamics. They do robot dogs. This is also very cool. They use reinforcement learning again, and that's Siri. And these are all other applications of AI. So I'm going to just go quickly, use the last couple of minutes to go through the quantum slides. So I was lucky to be in one of the projects that built the first real quantum network testbed based on entanglement. So this was a collaborative project between Berkeley Lab, UC Berkeley, Caltech, and also University of Innsbruck. And the main aim was basically to design a 3-node distributed testbed that will feature an entanglement swapping within this tree. So I am sure a lot of people know what a quantum. So think about it like if you have a quantum internet or if you have a classical network or a quantum network, and you now have a quantum network or a quantum internet, is going to be like 100x. Everything is going to be moving at the speed of light. There's going to be super fast speed when you have a quantum internet compared to when you have a classical internet. Then when you have a classical computer, comparing it with a quantum computer, same. It's gonna be super duper fast. And the kind of breakthroughs we're gonna have with quantum technologies, it's just unbelievable. So think about having things like this, in Africa, or let's say in Nigeria, how that's gonna change or drive a lot of things and change a lot of things. Okay. So this is what you start with a quantum node, and this did very good explanation of what a quantum internet looks like by Kimball. So you can have a read of this paper. He really broke everything down, and also a vision of the road ahead. So this whole quantum internet, quantum network, even in the West, it's still making waves, but it's the future. If you ask me, it's just like the way AI is going, that's how quantum is also going. So for those of us familiar with a classical network, on your left-hand side, this is what a classical network looks like. You hear things like packets, you hear things like packet forwarding, TCP/IP, and all that. When you now move to quantum, you now talk about what we call qubits. So in classical networks, you only know what you call bits, zeros and ones. That's what a classical network understands. Like you have routers, switches. What you transfer within those is just zeros and ones. When you now move to a quantum network or a quantum computer, all you know is what we call bits, qubits. So you guys can do some research and understand what qubits or how it moves. It's basically, so a quantum internet is a theoretical system of interconnected quantum computers that uses the quantum signals to send information. So it's going to be moving at the speed of light. So imagine we having a quantum internet, today in Africa or in Nigeria. That's going to revolutionize a lot of things. Okay. So this was a real life, the different nodes. So one was at UC Berkeley, one was, so this is what a quantum node, physical node actually looks like. Then they have a quantum server, and this doesn't communicate using the TCP/IP, the classical networks, it actually communicates through the signals of quantum. So that's actually the cool thing about it. So because this is just a proof of concept, they did it within a short region, not, very far. So everything within this was all based in California. And this is what the stages of development of quantum network. It starts from a trusted repeater, you prepare and measure, is what they call entanglement generation, the quantum memory, the qubit fault tolerance, then you get to quantum computing. Again, I'm going to share these slides so you guys can have some time, read about all these things, because a lot of some of these things, some of us might be familiar with and some might not be familiar with. So this is my last slide. Again, to round up with my initial slide I started with, which is data is the new oil. So again, the current, back in the days, engineers only studies using MATLAB and few codes, but with the current wave of AI, I always, upcoming engineers need to upskill, learn things like Python, data science and AI, because that's the only way you can analyze all this data, right? This data, the whole AI, the machine learning, it's all data driven. There's nothing on its own, it's not isolated. So data is the new oil and it's only valuable, but if unrefined, it cannot really be used. It has to be changed to gas, plastic, and etc. So if I give you crude oil now, it's useless, right? If I give you crude oil, it's useless to you, right? That crude oil has to be processed, maybe changed to plastic, gas or chemical before it's going to be valuable. So think about it, the same thing with data. If I give you a huge amount of data now, it's useless. You need to have the skills to analyze that data, to process that data, to get insights from that data. Then that is, still going to be, that's when it's going to be useful. So I know I'm running out of time. Again, I'm happy to have more conversations, and also please feel free to reach out to me, and I apologize if I've not done enough justice to the topic. So these are my contact details, and these are also some of the links again I'm going to share for some of the networks that they worked, and maybe for people that are interested in AI and machine learning, how to get started, how to learn some of these things. This will all be on all the on the slide once I share that. Okay, so I think this is question time now. Please feel free. Let's open the floor for questions.
Thank you, Dr. Bashir. We enjoyed your presentation. And really, because of the use cases, you see the participants are eager to learn, and also from their interaction with your questions, they are really matching on. It's time for question and answer, and you are to raise your hand and the question will be asked. If you also drop it, if you drop it on the chat, it will also be read out and he will be able to answer. Thank you for the great presentation, Dr. Bashir. We learned a lot. Yes, information is the oil of the 21st century, and actually, just like data is the new oil, information is also the oil of the 21st century. We've learned about the ways we can actually work in AI. Those that are in AI, you've learned new things today. Those that are still venturing into AI, big data, machine learning, you have also learned what you are venturing into. Thank you for the presentation. So we have the first person is Dr. Kennedy. After that is Professor Farouk. And I have Mr. Ilya. And okay, let's start with Dr. Kennedy. Yes. Doctor, you can ask your question. Doctor, sir, unmute yourself. You can ask your question now. Hello, Dr. Kennedy, your hand is up. Do you have a question?
All right.
Please
Hello, can you hear me now?
Yes, I'm hearing you. We are hearing you.
Okay, good. So let me start by thanking my very good friend, Dr. Bashi, for taking time to, make this presentation. This calls for a very serious, sober reflection on where we are in Africa and what we need to do to step forward. My comment will be that we have lots of persons here. I mean, we have experts within the AI field in this meeting, and we are trying to set up a special consortium, committee within the Amelion group. I want to ask, from the policy point of view, what do you think about regulation in terms of AI? Because there seems to be a mismatch within, on country levels. In the UK, their regulatory, idea about AI seems to be different, from what we have in US. And we're talking about harmonization of this, regulatory, perspective, so that we can have a common front in governing and managing, AI in general. So we'll have a kind of common protocol to handle AI, just the same way we have IP, and IP is the same for Africa, for Europe, for, any country at all. So what do you think about harmonization of regulation so that we'll speak the same language by the time we start implementing AI in systems and processes, so that we don't have a disjointed, protocols that will create confusion on country basis? That's my first question. I don't know if that makes sense.
Yeah, that makes sense. Yeah. Do you want to ask the second one, or you want me to go?
Okay, let me allow you to do this, and then I'll ask the second one, and then I'll leave the stage. Thank you.
Okay, no problem. Thank you very much. Yeah, that's a very great question. And that's a question I always get, asked. So one thing you have to understand with the way the Western world works is whenever they are doing a policy, it's just like when they were inventing the internet, Africa was never part of the equation. They never thought of Africa, right? So internet was, they designed it based on their specification, based on what they want, based on their needs, they never figured out. So we are just basically, we're not part of the equation. Just think about it that way. Right now, there is AI going on, the wave of AI. The UK are doing a policy, or Europe, they are doing a policy that, a policy based on their own needs and based on their requirements, right? They are not thinking about Africa. Africa is not part of the equation. Same thing when you come to US. I was lucky to attend, one of the AI policy. Like I said, I've also been doing some engagement in Capitol Hill with US Congress. And you see that most of these policies are thinking about their own people, about the system itself. Nobody is thinking about Africa. Okay, Africa, it's all down the line when something comes. So to be honest, in my own opinion, one of the ways we can drive this is the only people that can solve our problem is we ourselves, not outsiders. So one of the ways is to champion some of these ideas by coming together, right? So we have the African Union, which is a very good example of bringing Africans together. Africa is blessed, with talent. If you take a use case, just Nigeria alone, there is no organization in the world today that is no Nigeria. Start from NASA, Apple, Google, in the US Congress, in legislators, I've seen Nigerians. So we are blessed with that. I've seen Nigerians, I've seen Africans, we are blessed. So a lot of these things, we can really champion them and move them. And I think Emlon can also, because people are going to take you serious when you make a presentation to the government, to the Nigerian government, or, to other big organizations that have the power. Because, in another thing that affects us in Africa or in Nigeria is we have a lot of smart and good ideas. But when it comes to implementing some of these things, you need the right people to push these things for you. Otherwise, it will just end up, no. So back to your question, I think, coming together, with organizations like, like Emlon and others, can actually drive this. We have to be the drivers of some of these policies. We have to make sure these policies we are doing, is taken care of we as just the same way US knows their people, UK, their people. We need to start thinking we're using that perspective. If we want to make a law or a policy, let's think of ourselves first. How can that be useful and beneficial to somebody in, in any part of Africa or in Nigeria? So that's my little, I'm not a policy expert, but that's my little response to that.
Thank you very much. Dr. Kennedy, are you still there, or Professor Farouk can ask his own question? Professor
well, I think, thank you. My question is that it revolves around what Dr. Kennedy is saying. Because after this first stage, what stage are we moving to next in terms of helping the government to regulate it, set up a regulatory, and what are the conditions that we need to do that? I think the ESCO has to. This is a challenge for ESCO now to sit down again and look at it, so that we can determine what we're going to do next. I remember Samuel Oxley when it started. They started with a small committee, and the committee now developed and registered. And now they now say, okay, how would they regulate this thing? They now came in, okay, let there be a professional body, professional exams, let them look at the conditions, times, what needs to be certified. How can we do that in the industry? So that, I think we should be looking at how that what we can do to help in regulating it. It's a very key area, because as we are talking about it, AI has its own risk.
Yeah,
it has its own risk, and if these risks are not properly managed, to be like a flash in the pan.
Correct.
So we have to look at it very well. Thank you very much, Mr. Speaker. This is very practical and very, very, very direct. This is coming from industry like that. It makes a lot of difference when a speaker is coming from the industry and is able to share what is happening and then relate back to what is happening in the research. So it opens more door and gives more room for thinking. Thank you very much.
Thank you very much, Dr. Festus. He just mentioned a very good point too, which is the risk of AI. There's also ethical issues of AI. All these things are things that have to go into the policy. Otherwise, we won't. There'll be a lot of we'll have to bite our fingers in the future. So thank you very much for that wonderful comment and contribution.
Thank you, Professor Farouk. You are on.
Yes, thank you very much. Can you hear me?
Yes.
Yes.
All right, thank you. And I really want to commend also the organizers for organizing this summit. It's really insightful, and we really gain a lot. In fact, I'm currently on assignment, but I had to exit the flow so that I can join because I never want to miss this particular session. So thank you very much for the presentation. So I have one question, and the other one is just a contribution from the last about the AI policy, in which I think the speaker has already shared one of the reports, from the United States. And I was trying to follow some of the, country policies of AI. And I think China also came up with, new generation of AI developmental plan from 2017 to 2025, which they map out each year with a specific target of what they really want to achieve. So I think Nigeria, also through the Ministry of Communication and Digital Economy, and I think I have also read some of the, the move the ministry is trying to come up with.
Thank you.
Yeah. I think that's also a very
they have harvested so that yes, I'm very sure that the speaker may have been among the list because they gathered so many AI experts who will champion the process. So I would advise the organizers of this particular group to see how we can be able to fit into the drive of the ministry, because the process have already started, and I think they are in the right direction towards development of the policy. I'm not speaking for the government, I'm just speaking on what I've seen in the public space. So the other question is about the quantum networks. I'm speaking from both sides. My training was a physicist before going into telecommunication. So the issue or my dilemma was that, I don't know, once we are migrating into the quantum networks, are we going to change the whole protocol stack, or do we retain the layers of the protocols, and perhaps maybe there are so many other things that will change from the background? So I'm finding it very difficult to relate, because essentially if the fundamentals is missing, it's very difficult for someone to build up. So thank you very much for the wonderful presentation.
Thank you. Good, Thank you very much, Professor Farouk, for that great question and also contribution. Yes, so I think the Ministry of Digital and the Ministry of Information and communication and digital economy, right? They've been doing a lot of drive in, I'm also part of that. And I believe the Emlon is also in contact with them based on my information. So, but that's a very good comment. So the second question you have, you asked is about maintaining the stack. Yes, you are right. So at the foundation, there will still be some classical network protocols that will still be running, which is the TCP/IP, as you know, which is the fundamental protocol stack. And but at the top, that's what will have the quantum protocol stack, which will be based on those signals that will be transmitting, and it's going to be on mostly the qubits. So the interesting thing here is this is still a use case. This is still a proof of concept. Actually, I think the Department of Energy budgeted about almost about 100 million just for this project, and they actually wanted to start small before scaling up. So as I'm speaking to you now, they're in the process of building these 3 quantum nodes, which they call the Q nodes, which one will be in, and these are just within, let's say, 100 kilometers within themselves, right? So there was one in Caltech, one in Lawrence Berkeley National Lab, and one in UC Berkeley. And they want to demonstrate how a quantum network will look like in a small scale before scaling it up. So all the networks I've been showing are all classical network, right. But the QuantNet project is just the new project that they're trying to come up with a quantum network. But this is a proof of concept, and this is also at a small scale, but it's going to be real. It's not theory. It's going to be practical, physical quantum network, but within 3 distributed nodes. I can also add the link to that in case if you want to just read about the ongoing work and how far they've gone. So I hope that answers your question.
Yeah.
Very much.
Okay.
Nasiru, Ilya. Okay, sorry, Dr. Kennedy, please. Sorry.
Yeah, sorry. Yeah, brilliant feedback. So, Dr. Bashi, just as you observed, Amlion is making very strategic move. Our Ministry of Digital Economy, our Vice Chair and our ESCOs, we've been having close interaction with the minister. And at the point we had the request to present some use case scenarios and proof of concepts. And this concept of African Internet is something I think we're going to have extensive conversation with Amlion to see how we can drive that as well to the ministry, because they are actually looking for disruptive initiatives like this. So moving forward, we're going to get in contact. We'll have conversation currently going on that, and I believe with good political will, I'm sure something will definitely come out of it. That's for Amlion. The second one is that I'm a research professor with the University of Johannesburg, and we have lots and lots of postgraduate students doing master's, PhD. In this platform, I'm sure we have professors, senior academics that have, folks doing research within AI space. I just want to solicit and ask, does your lab have support for joint allied research so that we can have this kind of exchange engagement, especially for some of our brilliant and aspiring PhD students doing research within AI space with robust laboratories like yours? I'll be glad to have a feedback, and that will be useful to our audience, especially those of our colleagues from the academia. Thank you.
Yes, so Lawrence Berkeley National Lab has a lot of programs which I can share after the meeting, and it's targeted on, especially on, Africans, especially Africans doing, anybody interested in quantum, physics, AI, AI, because we are all minority in that space. Just don't even talk about Africa, talk about Blacks, for example. It's a space that we are all minority in that. So they are really trying to bridge that gap by encouraging more people to come. And there's also a lot of exchange programs, which I can also share some of those resources so the students can take advantage of that. Information is power, right? So a lot of this information, they are there, but people don't even know about them. So I'm happy to dig in and share some of those information.
Fantastic. Thank you so much. Got in touch. Yeah. Thank you. That's fine.
Thank you. Mr. Ilya, you have the floor now. You can ask your question.
Thank you very much, my prof. Thank you very much, the speaker, Dr. Bashir. For the first question, I think Professor Kenny has just asked. I wanted to ask about collaboration and how early researchers like me can explore and make use of the lab and the research direction. But I'm happy that Professor Kennedy has just asked, and that there is opportunity for that. The second question is, for us to be able to drive innovation fully in Africa, I think there is need to bring undergraduate students, postgraduate students, early researchers. In fact, or even the secondary school student that we have, we can take it down to them so that they should think on how to solve some of the pressing issues in Africa. So what is Emilian doing to take these innovations down to secondary school, undergraduate, and postgraduate students? The third question is regarding the resources, the slide, the material you have just read here. I think there are a bunch of opportunities for researchers, early researchers like me. Take, for example, in the area of autonomous, these self-driving technologies. I am very interested in autonomous research in autonomous drone and so on and so on. And I think part of your presentation, you make use of some advancement and so I would like to have such materials to be able to go through them. Maybe they will give me guide and directions. Thank you very much for the wonderful. And lastly, about joining this Emilian Association, what are the criteria and how can someone join, and so many other things? Thank you very much.
Thank you very much. There are some of your, like the last one you asked, how to join. It will come up after the question and answer, and it will be taken by a member of the association. So the presenter, you can go on now and answer the question. Thank you very much, Dr. Bashir.
Hello, I raised my hand too.
Yeah, so yeah, Nasiru asked
Are you still going to attend to other people?
Yes, everyone, you answer all your questions, please. After this is you. Just wait. Everyone's question will be answered. Thank you.
So yeah, I think Nasiru, I think Emilian Dr. Kennedy has also talked about how some of the strategic moves Emilian is doing, how they are collaborating with the government, and also maybe they will need to also work on introducing more programs that will get to the grassroots, like secondary school. Like in the US, some of the programs, some of the like related associations do is to introduce maybe like do sessions that have how to maybe learn Python. I didn't start learning programming at a very young age. I went to FUTMINA. I read electrical and computer engineering, and in my 5 years in FUTMINA, I only saw computer once. We have an Indian lecturer called Professor Khan, and he showed us what a computer looks like. And this computer is like the pregnant computer, this old computer with big screen and everything, So later I know how to save up and buy a laptop and all that stuff. So, but when I came, I saw my peers in the UK, the kind of things they're exposed. Someone told me he's been writing code since when he was 9 years old, 10 years old, and me, I'm an old man. I don't even know how to, so all these things, if we can go now, like what Nasiru said, expose some of these kids in secondary school to learn basic Python, it will go a long way. They'll be able to, start learning these things fast, because the whole AI thing, the foundation is all Python. Once you know Python, it's easy for you to go into data science, machine learning, and AI. But if you don't know Python, then you might struggle a bit. So then I think the other question is the collaboration with Berkeley Lab. Yes, I can initiate that. Some of the collaborations, actually, just for you to know, there are some research that are called classified research, which is on the national interest of the US government, like for national security. They don't involve, obviously, non-US affiliates, but for other researchers that are open, they are happy to involve people. There's internship programs, there's exchange programs, there's a lot of programs, basically, okay? So I'll share also my LinkedIn profile so you can reach out to the association, and I'm sure they'll reach out to me, and I will share all the resources with them.
Thank you very much, sir. Joe Uche, you can ask your question now.
Okay.
You are on. You
Can you
can
hear me?
ask your question.
Yeah, I can hear you. Go ahead.
Okay. Okay, I'm from TED Fund. I'm the director of ICT TED Fund. And this is really a very good presentation for us in what we are trying to do. We have a platform which we will try to reach out to you after this, because no need reinventing the wheel. A lot of things, just as you said, we can be able to bridge the gap to bring access closer to our tertiary institutions, making use of new technologies. Of interest is a project that Fund is currently doing called Terras, Tertiary Education Research Applications and Services Platform, which intends to aggregate common services in order to take advantage of economics of scale, take advantage of standardization, and reach out to our beneficiary institutions and solve problems faster and better. So we are looking at internet provisioning, we are looking at data provisioning, we are looking at subscription services for a lot of educational resources that our institutions need, among other things. We just had an agreement with Blackboard for an enhanced learning management system. We also have done an agreement with IFSCO currently, which we see up to 300 institutions have access to this. So basically what this for us is very important, that we can be able to make use of AI, make use of machine learning, make use of new and emerging technologies to bridge the gap faster and also give out services faster. So I hope that this is something we can be able to work on in collaboration with you, in collaboration with the association. Some members of the association were in the research committee that the fund worked on about 2-3 years ago. And some members are here. I have my director here too also, Dr. Mrs. Olotu. So we want you to comment on this, and I can even have a presentation sent to you on the platform we are doing, and now see how this association and you using your experience and where you are help us in accelerating the milestones we want to achieve. Thank you very much for the presentation.
Thank you, sir. Dr. Bashiru, sir.
Yeah, thank you very much. Yeah, I'm happy to to work and also to contribute to the little I can. Then I think it will also be good to collaborate. I'm sure Imlon is should also be someone that should be part of the to work together with, because the both of you have platforms, right? So TED Fund has a platform, Imlon also has a platform to reach out to, all the tertiary institutions also. So I believe it's going to be a good collaboration to come together. Again, I'm also happy to, be part of whatever will drive. Like I said, my main aim is to give back the little way I can, to my country. So I'm happy to contribute in any little way I can.
Thank you, sir. AY Shehu, you can ask your question now.
All right, thank you so much. My name is Abdul Wahab Yusuf Shehu, and also coming from the same platform that my boss have just spoken about, that's the TED Fund. Having TED Fund as a partner in this organization or this program you've just organized, I think it's one of the best things that is happening, especially in this very novel field, which is AI. And my question goes to Dr. Having thanked him for a very wonderful presentation and thanking the organizers also. My question is there any suggestion you can give us having TED Fund as a baseline, as one of the key financier or founder of all the tertiary institutions in Nigeria, is there any suggestions you will give in terms of incorporating these key, very important aspects of computing in our curriculum, especially the just concluded CCMAS, that is the core curriculum minimum standard that Nigeria used for all their tertiary institutions, especially the university education? The reason why I'm saying this is that, you see, basically you cannot give what you don't have. Professor Nasser have just said something, and I know he knows exactly what he was asking. The fact is that most of the lecturers don't have these key backgrounds that you're talking about in terms of having that very, very important early knowledge of these quantum technologies, AI, Python itself. Many don't even have the slightest idea about how these things work, not to talk of coding in it. Yes. So basically what I'm asking here is that what suggestion will you be giving, just opposing my comments with the CCMAS, the core curriculum minimum standard for Nigeria, and the experience you have in terms of achieving this all-important knowledge and or platform that you've just brought forward, and thanking also TED Fund for their funding of these tertiary institutions. Thank you so much. Thank you.
Yeah. Thank you very much. That was actually, an amazing point to come up with. And I really thank Imlon for also partnering with TED Fund. TED Fund is very, very key and fundamental. You have the you have the contacts, you have the funding, you have a lot of things that Imlon and other institutions can leverage on just partnering with you. So I'll start with your first question. So the first thing I want you to do is, there is an organization in the US, is called NSF, National Science Foundation. So National Science Foundation, if you ask me, is like the ETF of Nigeria. That's the equivalent. National Science Foundation. Just like ETF, they have funding from the government, and they drive research in universities in America. So any professor, assistant professor, lecturer trying to do research, one of the places you can tap funding from is NSF. You apply, you write a grant, you write a proposal, and you get fund from them. So back to your bridging the knowledge and the skill gap. NSF has different programs. Like I said, once you go there and you start reading about them, discard things that don't relate to ETF, but try and adopt or borrow some of the knowledge there. So they have various programs. They have programs for professors or lecturers already in the universities. Then they have programs for students, undergraduates. Then they have programs for like primary and secondary school as well. Okay, just to make sure everyone is on board on the same pipeline. For the lecturers and the professors, they try to identify what are the knowledge these guys give. That quote you just said, you cannot give what you don't have. You've just hit the nail, basically. No matter how we sing about AI and everything, our lecturers needs to be, empowered as well, right? So what NSF does is that they do this three-way program whereby they identify the things that are required for the lecturers, they empower them to get those skills. Then they come to undergraduate or the university level, the students, they empower them, they introduce programs, partnerships to empower them. Then they come to also the primary school and secondary schools as well. As far as primary school, they introduce basic stuff like, how to learn coding in an interactive way, all these things. And before that's how they strengthen their system. So if, in my opinion, if ETF can also start borrowing from some of this, experience of NSF, that will go a long way, because you have a lot of similar stuff. You have funding, you have the audience, you have the connections to all the institutions, you have the policy, a lot of things. So, and Imlon is also a very key partner in that. In whatever you're doing, Imlon is also occupying a very strategic position in terms of, the audience, the expertise. So I believe you should partner with Imlon as well in whatever you are trying to do. Professor Kenneth, I don't know if you want to add anything.
Thank you. Kenneth, you have another question?
Yeah, just to add, thank you very much. The speaker have really mentioned, has I mean, he has done justice to some of the questions. Just to mention that, Amelion, we have, you know, a plethora of professional and experts within the AI space. And I'm encouraging everyone in this platform to make sure you subscribe. From time to time, we have speakers around the globe. Bashi, you know, is talking to us from the US. Last time we had some persons from South Africa. This is the last event for the year. By next year, we're going to be having some experts from, you know, Manchester and all that. They were all talking about AI because that's the game changer. So for the universities, please, no one should, you know, hold anybody responsible for not being proactive. Meetings like this are quite important. There's no way you can have a magic happen if you don't participate, if you don't network, if you don't connect. You can't continue complaining that the curriculums are outdated. Everybody's complaining. You must have to take some action. So when you see programs and events, you know, like this could serve as an intervention. You connect. And then the curriculum of NUC does not really, you know, prescribe you from enhancing the content. As a lecturer, you're bound to do exploitative research, make findings, find out the trends, and augment the content. So we can't continue to talk about outdated curriculum. That seems to be a recurring decimal. I kept hearing that every time. The curriculums are such that as a lecturer, you can improve your content in such a manner as to improve reflect the state of the art, so that you don't teach students things that will be useless, that will not make, you know, meaning when they leave, you know, the university. So my advice for those that have this idea of, you know, curriculum being outdated and all that, please, I've been in the academia for quite, you know, a decade plus. I understand that you can actually do something about it. Connecting with Amelion, connecting with, you know, experts within this field through conference, symposium, and things like this can help you to understand what is going on, you know, help you to understand, you know, available resources, and then you can use that to improve what you're doing and even advise your department, your faculty. And then from there, the change will now begin to spring. So let's not sit and keep on complaining that the curriculum is bad. I mean, we can do something about it. In that space where you are, go back and take this message to them that, look, this is what is going on. This is how we can source for resources. Most of the things we are talking about, many of them are open source. Python have so much open source libraries, you know, but if you don't attend events, you don't know what is going on, it will be difficult for you to really, you know, follow the trend. TED is doing a whole lot, and we know we must have to appreciate the effort, but we more have to complement what they're doing instead of, you know, resorting to the blame of, you know, outdated curriculums and all that. Having said that, that is that will be my contribution for now. And then when we connect on our platform, we can share more resources. All the experts there are always available to give support where necessary. Thank you.
Thank you very much. There is nothing actually wrong with the Nigerian curriculum. NUC has done so much. I was there, I wrote the BMAS, and I was also there. I wrote the CCMAS, the 70% CCMAS. The 30% was left for the universities, where you sit down with experts. You can even invite NUC. You can invite another DAP, academic planning person, expert from another institution to help you to build the 30%. So all the emerging trends in your domain, in your area, you bring them in. And that is what universities did. And they got the remaining 30. That is your core.
Fantastic, fantastic.
When you come to computing, where you have 7 departments, 7 programs, that is exactly what was done. And then TED Fund has also helped in the book development, bringing professors together to write books, which covers all areas of those courses. And it can be used by all the institutions, making our curriculum to be stronger. So you can also enrich yours. What they did in the BMAS has advanced to CCMAS. Now, what is brought in is something that can look at cryptocurrency, blockchain technologies, and all this. There is even quantum computing. There is venture creation, not just entrepreneurship. A lot has been brought in to make the curriculum to be stronger, to make Nigerian graduates to be in pair with the foreign universities. Globally, they can stand to talk. Just like the presenter told you, there is nowhere in the world you will go to, you will see a Nigerian making an impact in that company, in that establishment, and so on. Look at where he is. And that will tell you that we have actually gone far. Nothing is limiting Nigeria. It's just that we don't have that environment, enabling environment. But once you engage, and that is what this association does for you, apart from the professional expertise, apart from collaboration and partnership, you can go far when you are in the association. Our student base, our graduate base, they are going far. And the postgraduate students are mentored, and they have people that move them into that particular AI or machine learning aspect they want to work on. So you can engage with us further. Thank you all for your questions. You have chance to bring in any other thing you want to. If we are going further, we have other things to talk about, but there is something I will actually want to speak on. Someone dropped a question.
Yes. Madam, can I say something, please?
All right, sir.
Okay, I just dropped a notice for we kickstarted a digital literacy webinar series anchored by Professor Jekwede, Professor Emeritus, National Open University of Nigeria. So we also want to invite you guys. We have done the first one, and we're on the second one that is coming up on Thursday. So these are all things that is being done, and we will also welcome contributions from the association and us as individuals in trying to enrich any of the processes that the fund is initiating that will help in gaining mileage in improving our educational environment, especially tertiary education. So we encourage you to register and be available for the Thursday meeting. It's only an hour long, and then we can be able to find space for it. Yes.
Thank you for the invite. If it is dropped or sent to us, we can also place it on our platform and also on our website. Members will be able to join in. And there is a question on the platform, on the chat. I don't know, Dr. Bashir, if you can take it as the last one before we round up. He said, what is the economic impact and benefits of AI-powered algorithm in Africa if it gets to Africa?
Well, the benefit is actually enormous, right? All the AI algorithm we're talking about have different applications. So I want you to think about that AI is basically a tool that you can use to solve problems. So I'll give you an example. I'm an AI maybe engineer right now. If you give me data that is related to transportation or aviation, I'm going to analyze that data. I'll give you predictions. I'll give you results. If you give me a data that is related to healthcare, African healthcare system or Nigerian healthcare system, I will analyze that. I will make predictions. If you give me data that is related to agriculture, like that. So think about it that way, that AI is a tool that can be used to solve various problems in various domains, not just one domain. But again, the bottom line, the driver there is what kind of data do you have access to? What kind of data is available? So it can be used to solve various problems from transportation to agri to aviation. All you need to do is to identify what problem you're trying to solve and how you can solve that. I give you an example. For example, anyone that has been to Kano or Lagos, you know, before, okay, for example, maybe Kano, where you have a lot of keke napep, bike, okadas and everything, and the kind of carbon monoxide that, you know, sometimes they emit. So think about it of bringing like the deep air project I shared. If that can be applied there, that can really, you know, minimize and regulate some of, and actually prevent, because that will advise the government on what to do, and they'll know how to curb all these keke napep that are polluting, or the okadas that pollute the environment with that air. Okay, so there are various, just so think about it that way. It's just a tool that you can use to solve various problems. And in Africa, we have various problems which can be used to solve, which AI can be used to solve. So let me also talk about Professor Nasiru. Just point out one thing I learned. I didn't know about this too, but it was when I went abroad that I learned it. So if you want to teach students maybe data science or program now, they actually don't need to use high-end computer systems for the first set of learning, basic learning. There's something called Google Colab. You can Google it, Google Colab. So Google Colab, you don't need to install anything on your computer. It's all web-based, and kids can write code. You just need to have a Google account, a Gmail account, and everybody can go there with the notebooks. There's what they call Jupyter notebooks. You can start to write Python codes, train your models, analyze your models. Google is so generous that they give some GPUs. GPUs are not like CPUs. They're like graphical processing units, which runs faster. So everything is all online. I learned this thing too in my journey of trying to learn about AI. And I organize seminars, I organize conferences, workshops, hands-on conferences on a place called Code Academy. And we all use Google Colab for that. The minimum requirement is just have an internet and have a web browser. And with Google Colab, you can do a lot of at least medium scale projects. You don't need very big, you don't need to even buy buy maybe like, big high-end computers. So, but again, what you've said is right. You need, our labs are flooded with 2 gig and 4 gig. At least if we have 4 gig, it's manageable, but 8 gig should be the ideal systems, not 2 gig. Yeah, thank you.
Thank you. That will be the end of our question and answer section. And I encourage all our graduate members, especially those doing their PhD, you can go further into RL concepts. You can also work on the Q learning algorithm using Bell-Marker equations. You can actually go deep into any of these, and you have the fellows, you have the mentors, you have people that will guide you through. Now we are going to also encourage you to go into quantum technologies. There are a lot of professors that have traveled to Germany and so on, and they came back and they're actually working as a team in different clusters in Futmina and 2 other universities to bring something forward. Now, if if you look at the time, you see that we've gone so far, and I will be calling on Dr. Kennedy to actually finish the rest, congesting it into just 5 minutes. Our membership and our involvement collaborations, a little bit of our collaborations with Europe, US, Dubai, and other proposals, and then step forward to talk about the 2024 conference. So I just have to use 5 or 6 minutes, Dr. Kennedy, to talk about this before we round off for the day.
Yeah, you're giving me a very tough assignment to talk about all these things. So I might have to borrow some AI algorithm, Bellman Ford algorithm from Bashi, to do this quickly. that seems to be the way out, So Bashi, you can set up a pipeline. Let me do that. Yeah. So thank you very much, Prof. You've done great, anchoring this program. Basically, Amlion is actually a platform for us to encourage ourselves. We know that the condition in Africa is really deplorable. But what we have in Amlion is actually a very solid soft landing zone. You can see that we've been bringing speakers, from around the world. These are Africans, these are Nigerians, and we'll have more in stock. I'm in Europe. Dr. Festus is in Scotland. We'll have members all over the place. So by 2024, we are proposing to have the first major land-breaking AI conference. We're going to be inviting the Berkeley Lab. Dr. Bash will just be expecting us. We'll definitely get back to you. We'll have several collaborating organizations that will be joining us to steer that conference. If you have expertise, in conference management and organization, I will want you to indicate your interest when we set up the call so that you can be part of the LOC to structure the conference. It's going to be a hybrid conference, actually, from all around the world. So the thematic area is going to be AI compliant, all the AI related domains. The communique for this event, we're going to share it, and then different stakeholders can have access to that and then be able to plan ahead. We have upcoming programs, but for the year we have closed for the year. The next program will commence from January thereabouts when we conclude with the next speakers. So that's for the conference. If you have any idea you want us to drive, I can tell you in Ambilion we'll have the best of brains in AI. We can be able to brainstorm and we can give support as much as possible. We are open to mentorship, supporting our research and industry professionals within this space, and then see how we can help ourselves to scale. Our conversation with the minister and several government departments are still ongoing. If you have any idea, please bring it on board. As we're engaging with them, we can throw such ideas, and that will be, the one that will, change the game changer. Like the African internet we are talking about, definitely it's an idea we're going to explore further, the proof of concept. So at this point, I want to welcome every one of us. If you are not a member of Ambilion, I will advise you to quickly do so before, we change some of our configurations. We expect that by this time, most of our members, the participants will, respond to the call for membership. So I'll add you to the platform and then you can engage with us. So thank you very much. And then I wish us a fruitful engagement.
Can I just say something?
Yeah, moving forward. Thank you.
Can I say something? Kennedy?
Oh, somebody's interrupting me. Okay, fine. I can lend you some. Yeah, go ahead.
You just mentioned about a conference management and all that. I'm volunteering to be part of it.
Yeah, we can talk offline. I just a general, announcement. I know we'll have lots of experts here, so we'll talk offline. But just get ready, just to let you know what is coming next.
There is something again. You talk about internet.
Yeah.
There is an organization they call African Aid Deployment Organization in Canada, who have signed an MOU with the World Bank. Presently asking universities in Nigeria to identify themselves for a presentation for them to have a huge broadband, 24 hours internet. They actually want to redeploy these services to universities to enhance our youth. And also building an ecosystem in all Nigerian public universities. But the universities want to politicize it. I don't know if there is any platform
please,
you can use to address that.
Yeah, I will advise, let's take this offline. The board of trustees can handle this. We already have a structured, framework through which we can channel some of these engagements. We are not political organization. We are, experts and professionals, and we do, our things in line with best practices. So let's engage after this meeting. We can take that offline and then see how we can scale that conversation. Thank you.
Okay, please, Professor Jefferson, I got you on the line. Please, just to chip in this, thank you very, very much for all I've heard today. It's really wonderful. This point I want to raise. The association, as big and very, very loud as it sounds, has not penetrated enough. More and more persons want to be part of this, but they don't know how and where. I want to put this to you, that I just took time to do a survey. Whole lot of persons are interested. The name is so big and catchy, but it has not gotten to the grassroots yet. What can we do to interface with those who will be interested? I see this association has been one of the associations with the largest number sooner or later, but we need to engage. Thank you. It's an observation.
All right. Thank you. Thank you very much. Prof, we are doing that, but we are a bit being careful. The association, we are doing a lot to make sure we scale and get the right, persons, in our membership database. What happened is that the conversation is ongoing, it's gradual. So there's a limit to what we can do at this point. All the membership requirements and criteria, we've specified them. Once people follow those process, we will be able to enlist them into the association. So, we are not, discriminating. We are just scaling and we'll keep on, admitting as many persons as possible. At the moment, people are still enrolling, and we need to do more in terms of letting people know, what's going on. But we have a process, and people have to follow that process. Thank you.
Thank you.
Thank you very much.
Yeah. So at this point, our director in Scotland, I don't know if Dr. Festus is here.
Festus, yes.
He might be the one that will help to close out this meeting. And then we can take it from, on our platform. The time is spent. Thank you.
Hello. Thank you very much. Thank you very much.
Thank you.
This is very, very impressive, and we are getting there slowly. The train have started, as I said, and a big appreciation to the speaker for doing such a great job for us and for all that's turned out for this event. Thank you, our moderator, the vice chair. Thank you, our executive secretary, Dr. Kennedy, and all our members of ESCO, and then the member of the board of trustees who are here, and then the members, those who have registered. Thank you so much for your participation. And we look forward to meeting you again, I think, in the next event. So have a wonderful weekend, and God bless you all. Bye.
Thank you. Thank you very much. Please, you can go to our website. It is dropped there now. You can go there and also read through and learn more. You can also meet any of the members online and discuss more. Thank you for participating in this, our last, actually the last in the year. And we'll get in touch with you for what we have planned for next year. Thank you, and God bless you all. Thank you very much.
Thank you, Prof.